Welcome. In this particular video, we'll be finding areas of triangles once you know the measures of two of its sides and an angle. Let's take a look at example 1. Find the area of the triangle shown below to the nearest tenth. First thing first, let's go ahead and label the parts so we can identify the components that we already know. So here, notice that the side across from angle A is what we refer to as side lowercase a. The side across from angle B is what we refer to as side with lowercase b, and the side across from angle C is side lowercase c. So we do know here the measure for angle B, which is 92 degrees. We also happen to know the measure for side B, which is 13.6 yards, and we happen to know the measure for angle A, which is 7.5 yards. Now, we can actually use this information along with the law of sines so we can figure out what is the measure for angle A. So let's go ahead and use that information, and let's write that sine of angle A over A is equal to sine of angle B over B. So let's substitute in the information here. So we have that sine of angle A over 7.5 is equal to sine of 92 degrees over 13.6 yards. Now here what we're going to do is to cross multiply. So we get that 13.6 sine of A is equal to 7.5 times sine of 92 degrees. Now we need to get the A by itself, so let's go ahead and get rid of this 13.6 by dividing both sides of the equation by that. So we get that sine of A is equal to 7.5 times sine of 92 degrees divided by 13.6. Now, to get the A by itself, we need to get rid of sine. And to do that, the first thing we're going to have to do is to eliminate it by taking sine inverse on both sides of the equation. So let's go ahead and take sine inverse on both sides. And that leaves you with A is equal to sine inverse of 7.5 times sine of 92 degrees divided by 13.6. So let's go ahead and get an approximate value for this one using our technology. For that, we're going to use a TI Inspire here. Just make sure that you are on degree mode. So notice here we're on degree mode, so we can take the sine inverse. So let's go ahead and find sine inverse, in this case of 7.5 times sine of 92 degrees, close the parenthesis, divided by 13.6. Let's close the parentheses and let's hit Control Enter. So roughly speaking, after we round to the nearest tenth, after we round here to the nearest tenth, we get that this is about 33.4 degrees. So going back here, we can say, well, A is about 33.4 degrees. So let's go ahead and write that information on our diagram. Now, in this case, we can either use this formula, area is equal to 1/2 times A times B times sine of C, or we can use any of the equivalent forms, which could be area equals 1/2 times A times C times sine of B, or area is equal to 1/2 times BC times sine of A. Let's see if we have enough information for any of this to be used. So notice we already have this side and this side, but we don't have the angle in between. Okay, we don't have that particular measure. In this case, we already know that this particular angle measures that, so we have this side, but we don't have the measure for this side either. So it would be faster for us to just get the measure of angle C, since we already have the measure for angle A, the measure for angle B, and we know that the sum of interior angles in a triangle is 180. So we can say, well, we have x, let me call this one x for now, plus 92 plus 33.4 is equal to 180. So we can say, well, x plus 125.4 is equal to 180. And after you subtract the 125.4 from both sides, we get that x is about, okay, and I'm going to include about just because in this case the measure for angle A is an approximation. So x is about, in this particular case, about 54.6 degrees, okay? So now we have enough information because we are given this side, and the angle included between them. So we're going to be using this first formula, okay? So one can say the following: therefore the area is equal to 1/2 times AB times sine of C, and after we substitute in the information, we get that the area is equal to 1/2 times 7.5 times 13.6 times the sine of 54.6 degrees. Now what we are going to do is to enter that into the TI Inspire so we can get an approximation to the nearest tenth. So we can type 1/2 times 7.5 times 13.6 times sine of 54.6. And let's go ahead and hit Control Enter. And notice that the area is about 41.6 after we round to the nearest tenth. So going back to the problem, we say that the area is about 41.6, in this case yards square. So let's go ahead and see another example, very similar to this one. Example 2. Find the area of the triangle shown below to the nearest tenth. Again, let's go ahead and identify what we already know. We already know the measure for angle C to be 114 degrees. After we label the parts here, that's side A, this is side B, and this is side C, we actually know that the value for B is equal to 4 miles, and the measure for C, lowercase c, is equal to 14 miles. Now, in this case, it would be nice to figure out the measure for A, but since we don't know the length across from it, what we're going to do is to use the law of sine so we can figure out the measure for angle B first, and then we're going to use the fact that these three angles will add up to 180 because that's the sum of interior angles, so we can figure out the measure for angle A. So by the law of sines, we have the following. We have that sine of B over B is equal to sine of C over C. So substituting information, we know that sine of B over 4 is equal to sine of 114 degrees over, in this case, 14. So cross multiplying, we have the following. We can say, well, here we have 14 times sine of B is equal to 4 times sine of 114 degrees. After we divide by 14 on both sides to get sine of B by itself, we get that sine of B is equal to 4 times sine of 114 degrees divided by 14. Now, our objective is to get the B by itself, so we need to take sine inverse on both sides of the equation. So let's do that. And one gets the following. Angle B measures the sine inverse of 4 times sine of 114 degrees divided by 14. Now, to get an approximation, we're going to use the technology here. So using the Inspire, we're going to type in sine inverse of 4 times sine of 114 degrees, all divided here by 14, close parentheses, and let's go ahead and hit Control Enter. So we get that the measure of angle B is approximately 15.1 degrees after we round to the nearest tenth. So going back, we say that B is equal to about 15.1 degrees. Now, let's see if we have enough information now. Since we know that this angle here is about 15.1 degrees, can we figure out the measure for angle A? And to do that, we use the equation x plus 114 plus 15.1 is equal to 180. So let's write that down. So x plus 114 plus 15.1 is equal to 180. So this gives us x plus 129.1 is equal to 180, and let's go ahead and subtract 129.1 from both sides. So we can get that x is equal to approximately 50.9, in this case, degrees. So this implies that the measure for angle A is equal to 50.9 degrees, or just about. Now with that given information and the previous information we knew, we can say that the area of the triangle is equal to 1/2 times B times C times sine of A. So we have that the area is equal to 1/2 times our B, but recall that your B we said was equal to 4 miles and C was 14 miles. So we can say 1/2 times 4, okay, times 14 times sine of A, which we said was 50.9 degrees. Now, entering this into our calculator, we can come up with the approximation rounded to the nearest tenth. So we can say area is about, and let's see what is that specific value after we use the inspire. So let's go ahead and type in 1/2 times 4 times 14 times sine of 50.9 degrees. And let's go ahead and hit Control Enter. So that's roughly speaking 21.7 square units. So going back to our original problem, we can say that the area is about 21.7 square units, but in this case our units happen to be miles. So this is in miles square. Therefore, one can conclude that the area for this particular triangle is about 21.7 square miles. So to conclude, in this particular video, we focus on finding areas of triangles once you were given the measures of two sides and an angle. Thank you for watching, and have a wonderful day.